In this tutorial, I will perform the XRD analysis, that how can we convert the XRD data or the XRD machine or raw data into a publishable graph. So for this, in some time we have the data in Notepad, or in some time we have the data obtained in Excel sheet. So here I have the data in a Notepad format. So first I will have to convert it into an Excel sheet. So for this I will have to open the Excel sheet first, and then open the Notepad in which contain the XRD analysis data of my sample. So from here I will have to select or Control A for selecting all the data, then Control C, or simply I can do this by this way. Then I will have to open a new sheet in Excel and paste it here. So the data I have put it or converted from Notepad to Excel sheet. So this is the XRD data of copper oxide data particle. So I have saved this sheet, and now I will save this file with myself in the folder where I want to save. So on the desktop I have this folder in which I will save it as copper oxide XRD analysis. So I have saved it. Now I will have to set this data for the JCPD cards or for the phase determination analysis. So for this I will have to convert this data into ASCII format or ASCII file, for which I will have to open the Origin software first, which will be again used for the graphical designing or for the plotting of the XRD graph. So first I will have to paste or copy the data from the Excel sheet, as I have selected both the columns. One contain the angle and the second one contain the intensity. So I will have to copy this and simply paste it here in the Origin book. Now set it here, or simply delete it from here, that it is the data rows. So I have pasted the data here. Now I will have to export this data or this column into ASCII files. So for this I will have to select a file, then goes to export, and then I will have to select the ASCII file. As I have selected the ASCII file, here I will have the type of the file or the data. So I will select the all file, and then CUO name is as copper oxide. So I will have to save it in the root folder or the data folder where all my data are saved. So I will have to save it as it. Now I will also have to select if here are these 4 options. So if there are other one, I will have to change it into all files. So it is already in all files, so I does not have needed to change it. So and I will have to save it in that root folder which is already selected. As I click on OK, my data is converted here into this file. Now I will have manually to rename it as .asc. So the data file is created, which will be used now by expert HighScore software for phase determination or for the phase indexing. So this file I will, for this analysis I will have to open the expert HighScore software, which I have already installed here in our system, which will be used for the phase determination or for the comparison of my data with some standards, that is called ICD cards or JCPD cards. So for this I will have to open the expert HighScore software. Now I will goes to the root folder where my data was saved, and simply drag this file into the expert HighScore software. I will have to reopen the expert HighScore as there is some issue. So I have started the expert HighScore software. Now I will go to the root folder and drag the file from here to expert HighScore. So as I have dragged the data, they are automatically fetched here and set it here. Now I will have to start the analysis for XRD for the finding the JCPD cards or standard cards which will match my data, the data or XRD data of my samples. So for this I will have first to perform the treatment. In treatment I will have to determine the background first. So the background I have accepted it. Now again I will have to stripe the K alpha 2, which is the standard used in the XRD analysis. So as you have got the data or obtained the data from XRD analysis or machine data, they will already show you the K alpha values to you. So the K alpha value, as I have already know that the K alpha value for my samples which was analyzed was 1.540598. So I will have to simply click on those step K alpha 2 and replace it with this. Now I will have to search the peaks in my data, that where the peaks were observed in my data. So I simply click on the treatment, then search the peaks. As I have clicked on the search peaks, here are some peaks are appeared here, or which will be set our minimum significance or tip width. Everything can be changed from here, as I have to select it as 1. Now I will have to select the peaks that where the peaks occur, but the 5 which was automatically drawn will be suitable one. Now I will have to check it on by 10 significance value and search the peaks. So it is more accurate that the most intense peak are here were determined. So I will have to accept that peaks and click on accepts. So these peaks were accepted for my data. Now I will have to compare it with the standard JCPD cards, or I will have to find the different JCPD cards with which I will have to compare my data of the XRD data of my samples. So for here I will have to click on the search and match. Here I will have to execute and match. Now I will have to search and match or determine the parameters or restrictions in which I will have to find the cards. So from here I will have to search it by the restrictions. So I will have to select the or edit the restriction sets. So as I have first clear all the data, then I will have to go to the periodic table. So I have already know that my sample was copper oxide. So the copper and oxide, so the possible cards for copper and oxides over here will be found by this way. As I have shown, you will have to first select all or none of these. So for this you will have to click on select all, then again click on the select all, and then again click on the select all. So all the elements were excluded. Now I will have to include the elements of or the atoms of my interest. So my sample contain the copper and oxygen, so I will have to double click on the copper, or simply one click and then again click it. So the green color show that this atom is included. Now I will have to include the oxygen. So 2 times I have clicked on oxygen, so it has been selected. Now I will have to click on OK. So as I click on OK, so all these elements were excluded except copper and oxygen. So now this software will find the JCPD cards only for copper and oxide, which then I will have to compare with my data. So I will have to first load the patterns. So I will have to click on search. So it has done. So as I have clicked on search, so I have found that there are 27 possible cards for copper and oxides here. So I will have to compare it one by one by simply that this is the reference. You can hear the number, serial number, and this is the reference code, which was the most important thing for the determination of your data. As if you have the XRD data and you have already know that the which card or which JCPD cards of reference code or of which reference code will match with your data, as you have not, then you will directly select it from here. But if you don't know the JCPD cards which will match your data, so you will have to compare it with all these data. So one by one I will select the cards and compare it here with the JCPD card, that these are the JCPD cards and these are the actual peaks or residue peak list of my sample. So I will have to select, I will have to test one by one. So the first one card will compare but not will. So I will have to go to the second one. Here are some peaks which will not match with my samples. As you can see here, there is a peak which is not match with my sample. It is here also in another peak, here also in another peak. So I will have to go down. These peaks also have some extra peaks which will not match well with my samples. Here are also some peaks which not match well. Here are also peaks or simply one peak that is not compared, but as compared to other they are match well. So I will have also to search and keep in mind that card number, serial number 5 will match well with my data, but now but also I have to test it with other cards. As you can see that here this card is matching well with my data, that all the peaks were matched with. So it is more accurate than the card number 5. The card number 11 is more accurate with accurately matching with my data. So I will have to keep in mind that a card 11 is also matching. Now I will have to test the others. So from all these 27 cards, I have found that the card number, serial number 11 is matching well with my data, except the one peak. So this peak is of low intensity, so it does not matter, but all other peaks are matching well with my data. So I will have to select the whose reference number is 00-002-1040. So this card is matching well with my data, so I will have to simply select this card and drag it here to the accepted pattern. As I have dragged it here, so it will match or put it here with my data. As you can see that the accepted pattern is that, the peak list of my sample is that, and this selected pattern of I have selected was here that. So now I will have to perform the XRD analysis from these two cards. So first I will have to find the cards or the accepted pattern. Here this card is accepted. Now I will have to first save this card with myself, as I can doubly click or simply show pattern, so it will show me the file. So it contains all the data of the samples. Now I will have to save it with myself. Save, as I have clicked on the save as, don't change the type, but simply click here. But I will have to copy the JCPD card number or reference code of this card, which was here, this. Now I will have to save it on this name. I will simply click as this card has become saved. Now I will have to find the peak lists and show here that these peaks were of my samples, and all the data of my sample which are here. Here you can see that these peaks, except the one peak of my sample which was first one, as I have already told you, that which was of a low intensity, that was not matching with the JCPD cards, but the remaining all the intense peaks of my samples were matching well with the JCPD cards. So I will have to simply copy the peak lists, as I have right click here and click on the copy list, and then open the Excel sheet where the data of my sample was saved. So I have to rename is as sample peak list, as I have copied the peak list from here. So I will have to simply paste it here. Sorry. So all the data was saved here. All the data was saved here in the Excel sheet, or I have saved with myself for to get the data that I have no need. Then I will have no need to open the expert HighScore software again and again and again. Now I will have performed the XRD analysis for the phase determination. So I will have performed the XRD analysis. Now I will have to save these analysis as on this point for future use. So I will have to save it as. Sorry, I will have to select or save document, save. Where does it go on? Expert HighScore. So I will have to save this project as copper oxide XRD phase determination. So I have saved it with myself on the same root folder here. So I have to save it. Now this data was saved, as I have obtained the JCPD card and the peak list of my sample. So I will also have to copy the JCPD cards. Now I will have to go to the root folder where the JCPD card is I have saved was present here. The page determination export file was also here. Now I will have to open the JCPD card and copy the peak list from here. Now I will have to set the data in the different columns, so I will directly go to data, and here I will have to click on text to column. So as I have to text to column, next, and then finish. So you can see here that the data was directly converted into columns. So from here the JCPD cards are what's the number of the reference card which was here. Now I will have to compare the data or the peak list which was matching with my samples. So matched. So all these peaks were matched will except the first one. So now I will have to put the HKL values or HKL indices or Muller constants here from JCPD cards to there in the sample peak list which was empty. Now I will have to select the peak of my samples was starting from the 2 theta 32.53 sorry 32.53, the peak which was not matching well with the JCPD card. As you can see here that the peak at the 32.53 was not present here, as it started from 35.598 2 theta. So I will have to simply select here 35, 38, 48, 53, 35, 38, 48, 53, 58, 61, 66, 58, 61, 66, 68, 72, 75, 68, 72, 75. So it is 67 but near to 68, so I will have to accept it as it. Now I will have to copy that these peaks were matching well with my data up to 75. Up to 75 I have selected it as. I will have to copy, this is the JCPD card file, so I will have to copy all these values, that all these values are matching with my peak list. So here this peak was excluded. I have peak here which I have also excluded in the JCPD card, but here the JCPD cards values are matching well with my data. All the first 10 peaks were matched well with my data, so I will have to copy these values and put it in my. So these values are matched well with the JCPD cards. Now I will have to construct or form the graph, or as I have told you in the start, that how can we convert the machine data to a publishable graph. So I have performed the analysis and I have got the values, the HKL values are indices, Miller indices, the peaks, FWHM, all the data I have obtained by XRD page analysis by expert HighScore software, and now I will have to go to the origin software where I will have to put the data and draw a attractive graph from the machine data. So here this column represent the angles, and this column represent the intensity of units of all the samples, or all the columns, or all the values, or quantities are here present now. But here you can see in all the papers are in different various literatures that here the angle is represented by 2 theta. So I have to write the 2 theta. Now I will have to draw a graph, and then we'll have to decorate or make it attractive. So I will have to simply select the columns from which I will have to draw the graph. As the graph has been drawn, now I will have to perform the setting of this graph. First I will have to select the range and the scale, which will be started from here. There is no peak, so I will exclude this data, and here this data was up to 90, so I will have to select 10 to 90, and vertically this start from 0 to 3000. I can change it as like 3000 to no, it will better like this. Now I will have to draw the grid lines here, horizontal opposite and vertical opposite. As I apply it, so I will know the border or become visualized. Now I will have to enlarge it, as these micro tick levels are here present, but the ticks are present but having no labels. So I will have to put on the labels on. So it is the horizontal line. First I will have to go to my horizontal line, then I will have to select on tick labels, and then go to the minor legs, show at each minor tick. So as I apply it, it becomes visible. Now I will have to remove the values from the left side. So I will have to select here like this, then apply. So these become invisible. Then I will have to select on line and text. So on vertical side I have not needed the text, the line has already drawn, and I does not needed the text, minor text and major text. So I will have to remove the major text like this. As I have selected line and text, then I will have to go to major text, then select the none, then scroll it down, and also here the minor text none. As I applied, it become invisible. Now I will have to set up the size of the axis title. So it is normally of 36. You can use your own size, but I have used the font size 36, and I have doubly clicked it on it, and then select all by Control A, and then select on B. So it become bold. Now I will have to increase the size to 36, font size to 36. Now I will have to set it in different axes. Now I will have to select the bottom line levels and change the size of it, or enlarge their size to 22, and also become make it bold. That now I will have to set the graph, as I can select as I see here that this space is having no peaks and take more space, so I will have to change the scale from 20 to 90, so it become so good. Now I will have to change the or set the size of the spectra, so I will have to click on it as the spectra has been selected. Now I will have to select the size, as I have selected size 3 and make it 4, but now I will have to change the color of this graph, as I have selected the blue color. Now I can change the ligands, so this spectra is for the sample copper oxide, so I will have to change the ligand like from here, as I have double click on this. Here you can see I will have to change this numbering or codes is for the line, and this code is for the value, so I will have to remove it and simply write CUO. So as I click on apply, it become copper oxide. Now I want to become bold it. Also I want to change or to increase the size of this ligand to 26, so it become increases. Now I want to change the symbol, the frame, or the make it more attractive, the frame of the ligand, so I will have to click on the frame, then I will have to select the shadow and apply. As you can also select the marble type like this, but the shadow one is more attractive, I think. Now click on OK. So you can also change or increase the size of the ligand from here like this. Now I will have to put the Miller indices or the plane for diffraction planes to each of the peak, that which peak represent our diffraction from which plane. So this the planes, the data of the plane I will have to get from the XRD analysis that I have already performed here. Sample peak list, here you can see that the sample peak list contain all the data here, so you can simply put it or fit it here, or simply copy it from here, or for your easiness you can also do like this, that you can minimize it and also open a book. Then from here you can select these peaks, Control C, then go here and paste it. Now go to the HKL values, simply copy it and paste it here. So you can put it from here. There the peak at 35.59, the peak at 35.59 was here. This peak represent which plane, diffraction from which plane, so I will have to simply write it here that this peak represents the diffraction from 002 plane. So I will have to simply write 002 plane on this. Now I will have to set the setting of these values or labels. This peak represents the diffraction from 002 plane. Now I will have to check the 38, the peak at 38, so it is here. So I will have to select this or simply copy it, but I will have first to select the values and then I will have to put their respective values. 48, this was diffraction from 48, 53, 58, 53 and 58 and 61. So I will have to copy these values from here. So I will have simply copy these values from here and put it here. That's why I have copied it, that I have does not needed the by this way I have does not needed to change the style or size or make it the size or the same size. So in the last I will perform the changes in the value, that their respective values of each peak will be changed or put it here. Now 66, 68, 66, 68, 72 and 75, 72 and 75. Now I will have to change the values, the HKL values of the respective peaks. So the first peak at 35.59 have the plan HKL value 002. The second one have the values 1111. So I will have to double click on it and simply write here 1111. Now the third one minus 202, minus 202. Minus 202. The diffraction peak at 53.48 can have the value of their plane 020. 61 minus 113, minus 113, minus 113. Then 022, then 113, 3, then 311, then 004. 75 contain the value 004. The 72 have the value 311. 311. 68 have the value 113. 113. The value at 68 and 66 have the value 022. 022. The value at 61 have minus 113. Minus 113. The value at 58 202. At 58 was 202, and the value at 53 was 020. 020. 48 had the value minus 202, and the value at 38 was 111, and the diffraction peak at 35 2 theta was diffraction from the 002 plane. So all these values was put. Now I will have to set it, as I will have to make it as normal as I have make it bold. So all the values are put here. Now I will have to export this graph. As this graph has been completed, now I can put it in my research article or in a thesis for the discussion or for the XRD discussion. So I will have to save it in the picture form. So for this I will have to go to the file, then click on export, and then goes to open dialog. Then I will have to select the type PNG, name XRD APH graph of CUO, and the picture quality or resolution was 600, and click on OK. I have also to save this project or this origin file with myself for further or for future use, or simply that if I have want some changes in this graph or in these values, so I can do it easily from this stage. So I will have to save the origin file also as save project as. Simply select the root folder and click here XRD graph graph of CUO. So the project becomes saved. Now I will have to close it. Also close the JCPD card, close the Excel file, close the notepad, and open the folder where all my data was saved. So here you can see that the JCPD card was here is this, ASCII file was this, copper oxide Excel sheet was this, which contained the XRD analysis data or interpretation data. This is the raw or machine data file. This is the expert HighScore file for XRD interpretation or analysis, and this is the finalized graph or a publishable graph, which I can put it in a research article or in thesis to be published. Sorry, this is the origin file. As I think the graph was, so I have to again save the graph which was saved. I think I will have to again save this file or this graph in the picture format. So I will have to select the PNG XRD graph. So where I have do this mistake that I have not selected the location. So from here I will have to select the location where I want to save this picture format of the graph. So now I have selected the picture format, select the quality and click on OK. So now you can find the graph in a picture format here in this folder. You can see here that the XRD PNG file was saved here. You can see here it here in the picture format. Now you can simply copy this picture and paste it in the Word file where you have to discuss it. Now I will have to copy the picture and simply paste it here. So you can see, give it a proper fraction, caption, figure 1 XRD of CuO copper oxide nano particle. So this is the caption of your graph. Now you can simply discuss it like that. This is the figure 1 contain the XRD graph of the copper oxide nanoparticles, which will give peak at 2 theta values as 35, 38, 48, 58, 53, 58, 61, 66, 68, 72 and 75, which correspond to the XRD diffraction plane 00211, 0202, 020 and so on up to 004 respectively, which are in good agreement with the standard JCPD cards. Mention the number of your JCPD card with which your sample data was matched as the JCPD card reference code 00-002-1040. So you can do the XRD discussion by this way and also give some references of already reported data which matched well with your XRD graph or your XRD sample analysis. So thank you for watching this tutorial, and I hope that it will help you well for drawing a publishable graph from the machine data or XRD analysis of your samples.